Okay, so here's the example that we did in the last video. So now we know how to compute a confidence interval. Let's talk a little bit about the margin of error. So what is the margin of error for this confidence interval that we did? Well, the margin of error is the part that we're adding and subtracting to our sample mean. Okay, so it's this bit, the 2.576 times 5.2 divided by the square root of 25. And what this is telling us is about how far off we think our sample mean is from the true population mean. So if I plug this into my calculator, I'm going to get approximately 2.679. So the margin of error here is 2.679. Now, this is called a margin of error, and so you might be interested in trying to make that small, right? We want small error. So let's talk about that. How could we get a small margin of error? Well, the formula for the margin of error looks like z star times standard deviation divided by the square root of n. So we're going to get a small margin of error if we can make these variables in the formula small. Well, the first thing I could do is make the z star smaller. Well, how could I make z star smaller? So look back at the table with the given z-scores, or think about the picture. Let's try that again. Whoop, I'm terrible. Okay, something like this. Remember, z star is telling me that the area between negative z star and z is my confidence C. So if I want z star to be smaller, that means I want z star to come in this way. But what is that going to do to C? Well, that's going to make C smaller also, right? So by making my margin of error smaller, that also makes my confidence smaller. What else could I do? Well, I could make n larger. N is in the denominator here, so making the denominator larger is going to make the whole thing smaller. So larger sample sizes are going to give me more accurate estimates. But if I'm a researcher, larger sample sizes also cost more money, so I have to balance that with the cost of doing a larger sample. And the last thing that we could change is the standard deviation. The last thing that could help is the standard deviation, but we can't really change that, right? That's a fixed value, so we don't have a lot of control with that. Now there's a link here in your slides to the Gallup poll. I'm not going to click on it here, but I suggest that you go to gallup.com. They do a lot of polling, and look at how they report their polling. What they'll do is they'll give a mean like we just did. So they'll report the mean score for all students is 78 with a margin of error of plus or minus 2.679 with 99% confidence. Okay. All right, so let's see what we can do when we change the margin of error. So we're going to look at weight of raspberries from a you-pick farm. We know it's normally distributed with a standard deviation of 1.3 grams. We've taken a sample of 24 raspberries with a mean weight of 4.8 grams. Let's find a 90 and a 98% confidence interval for the mean weight of raspberries on the farm. How do the margins of error compare for your confidence intervals? Okay, so let's start with the 90% confidence interval. Whoops. So again, my formula I'm going to write here, x bar plus or minus z star times sigma over the square root of n. So what do I know? I have x bar is the mean weight, 4.8. I know sigma is 1.3, and I know N is 24. There were 24 raspberries. All right, so for a 90% confidence interval, well, that's one in my table. What's the Z star, or the critical value for a 90% confidence interval? It's 1.645. Okay, so what should I do? I'm going to take 4.8 plus or minus 1.645 times 1.3 divided by the square root of 24. All right, that's going to give me a lower bound and an upper bound. I'm going to plug all that into my calculator. I'm going to get 4.363 for my lower bound. And then if I add, I get 5.237. And what is the margin of error here? Well, this is the part that we're adding and subtracting, right? So what is that? I get 0.437. All right, let's do the 98% confidence interval. Now for the 98% confidence interval, this one is not in your table. So you're gonna have to look in the Z-score table. All right, so we're gonna look in the Z-score table. And we want to look for an area of what? Well, I'm going to take my confidence level and convert it to a decimal and then divide by 2. So what is 0.98 divided by 2? 0.49. So we're going to go to the table and we're going to look for an area closest to 0.49. So why don't you pause the video and look for that. All right, so hopefully you found it. What I found is a Z-score of 2.33. All right, and now let's find our confidence interval. So I'm going to have 4.8 plus or minus 2.33 times 1.3 divided by the square root of 24. I'm going to type all that into my calculator. So for my lower bound, I get 4.182. And for my upper bound, whoops, I get 4.618. And what is my margin of error? Well, my margin of error, again, is the part that I'm adding and subtracting. So I'm going to plug in 2.33 times 1.3 divided by the square root of 24. And I get 0.618. And so how do these margins of error compare? Well, you can see that for the higher confidence level, 98% confidence level, I have a higher margin of error, right? This is larger than this number. So by increasing my confidence, I'm also sacrificing a little bit in my error. I'm going to get a larger range in my confidence interval.